What makes the Terrex special is what the engineers like to call a system of systems. The Terrex integrates 8 main electronic systems into a smart infantry carrier vehicle that is made to perform in networked operations. Integrating the systems is Vetronics engineer Terry Chan. His team is responsible for linking all the subsystems in the vehicle while ensuring each performs its main task robustly.
One of the systems is the weapon detection system, and we have the navigation system, the battlefield management system, the remote control weapon station.
An all-round surveillance system, supported by 11 cameras on board, enhances the troops' overall situational awareness, even as they remain well protected within the vehicle. Like human ears, the weapon detection system listens to gunshots from firers and determines their locations. That information is passed to the brain of the vehicle, the battlefield management system, where the vehicle commander can then make his decision whether to engage and return fire. Should a retaliation be necessary, the remote control weapon system will slew to the target and engage accordingly. The beauty of this weapon detection system is that it can mask its own fire shots, thus targeting only the hostile forces. Beyond the systems, human factors engineering features prominently in the design of the Terrex. Principal engineer Ravinder and his team study ergonomic design factors and analyze their impact on the physical and psychological comfort of the soldiers.
This is a digital model of the Terrex. We use human modeling and simulation software for all our human factor studies and analysis. What you see here is the driver compartment, where we use the software and human factors standards and guidelines to actually help us place all the components that you see that are used by the driver in all the correct and perfect positions so that he can actually use them effectively and perform his task well. This is the troop commander here, where you can see the troop commander actually giving a briefing to the other crews. This is where we ensure that all the troopers that are seated inside the vehicle can be accommodated in their respective areas comfortably and effectively based on whatever body size they could be of, whether large or small soldier sizes. This here, what you see here below, is his actual binocular vision, human vision of the troop commander. So this software allows us to see what the troop commander is actually seeing inside of the vehicle, to see if everything can be seen clearly, whether there is any visual obstruction to anything that he's supposed to see.
A prototype machine is built to specifications and put through numerous stress tests to assess its performance. Built to function for at least 15 years, the vehicles need to stay reliable and safe to operate at all times. It should also be easy to maintain by the user. Stringent tests are carried out to stress the machine to its limits. All the components are examined under controlled environment. At this stage, failure of any part is thoroughly reviewed and analyzed before the machine heads back to the design office for modification. Computer-aided design and computer-aided manufacturing programming are combined in the design and development phases. With over 1,000 parts to be assembled in the production of a Terrex, a seamless flow of data from engineering to plant and plant to machine is necessary to reduce production lead time and to increase overall productivity. Tracy Teo is an industrial and operations engineer whose role is to increase productivity by making things work better at the plant.
We did a time study and found that workers are spending a lot of time looking for the right tools, the right material, and also sorting out their workplace. So to raise productivity, we actually color-coded the floors. Green represents the walkway, blue is the material holding area, and grey is their working space. We also color-coded and tagged all the material parking lots for them to easily identify the right material to work with. At the same time, we also put in a dedicated tool racks at every workstation and replaced all their manual tools with power tools. While it has been rewarding to see all these changes happen in this shop floor, we also faced some challenges, especially at the beginning. So what we did was that we identified a small team of young workers and we gave them power tools to work with. And then slowly we found that other stations were borrowing their tools because it was so much easier to work with. And this was how we actually got the buy-in from the older workers to trade in their old manual tools with electric power tools.
Technology has helped to make heavy-duty work more palatable for the workers, causing less strain and raise productivity. Now, advanced tools such as air manipulators are used to install wheel hubs onto vehicles. With the manipulator, the weight of this 200-kilogram wheel hub is reduced by about 90%, making installation much easier. This operation done manually in the past used to require 4 men. Now, 2 is enough. ST Kinetics has a dedicated team of engineers and technicians on duty 24/7, 365 days to provide repair and maintenance services. It's a promise to give its clients peace of mind.
The customer have raised a job saying that the Terrex remote control weapon station is faulty. I will be doing the diagnosis for the fault.
Advanced built-in test systems on board the vehicle helps to quickly pinpoint faults that occur in components. Full diagnosis and rectification can be carried out quickly, minimizing downtime for the user. With the sheer number of electronic systems built into the vehicle, maintenance could pose a major challenge to any experienced technician. To solve this problem, the Electronics Technician program features a simple plug-in under the driver instrumental panel. With an easy connection to the diagnose kit, the technician can check the status of components, from engine and transmissions to anti-lock braking system. An electronic manual is available to aid technicians in troubleshooting when they encounter a tricky problem. Also designed as a help tool for users, this easy-to-understand manual contains vehicle operation guidelines as well as maintenance information. Despite the complexities of the Terrex's system, timely fault diagnosis and rectification support for the customer is a promise that will not be compromised.
We start this design of this vehicle from scratch. Some don't really believe we can build it in Singapore. But at that time, we recruit the engineers that have the passion and then show very strong perseverance in acquiring the knowledge. We are able to compete with an international player, okay? To the extent that the people from US actually invite us to bring our vehicle to participate in the defense program.
It is such a success story because the manufacturing team and engineering team works hand in hand together right from the beginning. We ensure that all our designs of parts are for fabrication and assembly. The manufacturing team uses productivity tools to ensure that all our production is efficient and consistent in our quality. That's why our virtual engineering model became a real vehicle as of today, and we are so proud of it.
It's tough, it's challenging, but the satisfaction of going through all the hardship, and then in the end be able to meet the target and getting the results that we want, and also making our customers happy. I think that perhaps would be the best part of the journey.
The successful development of Terrex is an important milestone for ST Kinetics. We started out in 1967 producing bullets and doing some contract manufacturing. And 45 years on, we have actually progressed on to develop advanced systems such as the Bionics, Bongo, Pegasus, SAR-21 assault weapon, as well as the full range of ammunition. And not to mention other systems that's ongoing development. We have actually come a long way.
This program was brought to you by ST Kinetics, a company of ST Engineering.